Do subscribe to SU Learning YouTube channel and press the bell icon for new update.
नमस्ते दोस्तों, हम देख रहे हैं 11th स्टैंडर्ड का एनसीईआरटी मैथमेटिक्स का सेट चैप्टर नंबर 1 सेट्स। इसके लिए मैं सतीश आपका स्वागत करता हूं एसयू लर्निंग में। तो आज हम देखेंगे व्हाट आर प्रॉपर्टीज ऑफ सेट्स। फॉर दिस आई विल एक्सप्लेन सम रिलेटेड टर्म्स, देन वी विल सी द प्रॉपर्टीज ऑफ सेट्स। फर्स्ट टर्म इज वेन डायग्राम। From its name only, we can understand this is kinds of diagram where we will represent our sets. Means some diagrams that are used to represent operations on set are called as Venn diagrams. Generally, Venn diagram consists of rectangles and closed curves. In general, there are circles. Means rectangles are considered as universal set, and the circles are nothing but subset of that sets. That circle consists of element of that set, that respective sets. For example, here I am considering my rectangle as universal set equals to R. Okay, and I will consider my some set A as set of rational numbers. Okay, now then I will write here some set B as set of irrational numbers. Definitely, set of rational number and set of irrational number is subset of R, which is nothing but universal set that are represented by circles. That circles will consist some dots that are represented by its elements. Means in Q you will have numbers in the form of P by Q that are represented in A. These are your Venn diagrams. Now, actually, we will use these Venn diagrams in operations of set. How that is going to be useful to us, that we will see in next concept as operations on set. Okay, the next headline is operations on set. In which first operation is nothing but union of set. Now, what union of sets consists? Suppose you are having set A and set B. The union of set A and B will consist all elements from A and all elements from B. Means you will have A union B as new set. It will consist all elements from A and all elements from B. We will ignore the set elements that are common to A and B. Means what? Whatever A and B has become. Suppose I will write one definition for it. Suppose A and B be the two sets. Okay, then A union B is given by the set having all elements from A and all elements of B taking together excepting elements that are common to A and B. I will not consider the elements that are common to A and B twice. Means I will not accept it. I will just consider once elements that are common to A and B. Means what? I will consider the elements of A and elements of B taken together, but I will not consider the common element twice. I will just take them as once. Okay? We consider A and B as once. How A and B is denoted by? For example, my A is this. Before that, I will write denoted by. How it is denoted by? A and B is denoted by this symbol U. Okay? And now I will write the formal definition for A and B in terms of mathematics. It as A and B equals to the elements X that are X belong to A or X belong to B. Means what? Your element must be from A or all elements from B as well. We will not consider both elements from A. We will not consider the common element twice. Your element must be from one of this set. That will be A union B. For example, now I am having my A set as 1, 2, 3 and 7, and my B set as 3, 4, 5, 7 and 8. Okay, these are my two sets. From this I will get my A union B. Okay, what will be my A union B? I will consider all elements of A first. A, 1, 2, 3 and 7. Then I will go for B. That I will consider that element that are not in A. Means I will ignore the common elements here from B. Now 3 is there, 4 is new, 5, 7 is there and 8. Means I have not taken the common element twice. I have just considered once that common element. These are all elements are coming from A and coming from B. This is your A union B. Okay. This was definition of A union B. I will draw this definition in terms of Venn diagram. For example, this is my universal set. From now, we will consider all these subsets A and B are subset of some of the universal set. Means what? हमें कौन से भी set जो भी consider करेंगे वो किसी एक universal set के subset consider करेंगे. Okay? What universal set consists of? It consists of entire subset family. Okay? That universal set is. Means we will consider that A and B in particular some subsets of union of one universal set. Here it as U. Now I am having my set as A here and my subset as B. Means what? I am having 1, 2, 3, 7. 1, 2, 3 and 7. Okay? This is my A set. Now my B set is 3, 4, 5, 7 and 8. This is my B set. Look at here. I am having my A as 1, 2, 3, 7. Okay? This is my set. And now I am having my B as 3, 4, 5, 7, 8. 3, 4, 5, 7, 8. This is my B. Now what is my A union B? Here it is. It is A union B as 1, 2, 3, 7, 4, 5, 8. 1, 2, 3, 7, 4, 5, 8. Means all these things is nothing but my A union B. Okay? This is my A union B. By Venn diagram, it is clear that the entire set A and B is your A union B. Okay? After this, we will see some properties of union A, B. Okay? What is your first property? First property says A union B equals to B union A. Means A union B can be calculated by B union B as well. For example, now suppose I will consider A union B here. What will be A union B or X such that X belong to A or X belong to B. This can be written as or X such that my X belong to B or my X belong to A. But by definition, what this is A or B. Here B or A means this is nothing but B union A. Okay? Means for all A and B subset of U, A union B is equal to B union A. This is nothing but what this implies. This implies my union of sets is commutative. We have considered A and B in general, and that gives A union B equal to B union B, B union A. It means my union is commutative. Now, second property. What is my second property? It tells A union B union C equals to A union B union C. That you can verify. Okay? Means you can have A union B union C as A union B union C. This is my second property. What is my third property? Third property says A union phi is equal to A. Okay? A union B phi is same as A. We will verify whether it is true or not. What is A union phi? A union phi is nothing but or X such that X belongs to A or X belongs to phi. Okay? Means what? You need to take all elements from X or elements from B. Now I will not have any element from Y, therefore I will only consider element from X. What this means? These are nothing but X such that X belongs to A only. Means you are having no elements in phi, therefore you are having X belongs to A only. It means A. X such that X belongs to A is nothing but A. Means A union B, A union phi is nothing but A again. Okay? And that can easily check this as phi union A. Means phi union A will become A. Means what this gives you? Phi is nothing but identity element of union. Therefore this property is also called as identity property. Okay, this was your third property. Now we will see what is your fourth property. We will see the fourth property as what will be your A union A. Can you imagine what will be A union A? For this we have to apply definition only. It will be A union A as X such that X belongs to A or X belongs to A. Are you getting? A union A is nothing but X such that X belongs to A or X belongs to A. This is our definition of union. Well, what this implies? X such that X belongs to A or X belongs to A means what? Your A must be from A. Okay? This is nothing but A. What this implies? Your A union A is A. This is nothing but union is idempotent. Okay? Next. This was your fourth property. Now we will go to fifth property. What will be your A union universal set U? It will be set X such that X belongs to A or X belongs to U. Means you will take all X such that X must be A or X must be belong to U. Now you know A is subset of B, that we know. A is subset of always U, universal set. Means what? This X such that X belongs to A, which is subset of universal set. Okay, what this means? Your X such that X belongs to U only. What this is nothing but whole universal set U. Means you will have A union U as universal set U. This is called as universal property of union. Okay? These was all properties. That properties you can verify by using one examples also. Now we will see next definition. It as intersection of two sets. What it is? It is nothing but intersection of two sets. Okay? Means what? We will take two sets A and B. We will take intersection of that two sets. Okay? For example, I am having any two sets A and B. Then intersection of A and B is given by all those elements. Those are common to A and B. Means your element must be from A as well as from B. Means the element that is coming from A and B commonly, that I will consider it as intersection of A and B. Means here, suppose A and B be the two sets, then your intersection of A and B is given by the set containing elements that belongs to A and set B. Okay? Means you will consider all those elements that are in A and are in B. Means we will consider all those elements that are common to A and B. How it is denoted by? It is denoted by the symbol this. Means your A intersection in B is written as, and here it is given as A intersection B. It is written as, it is A intersection B, and it is given by all those elements, okay, that are X belong to A and that X must be in B also. Means we will take X from A and X also belongs to B. Then only we will consider X in that A intersection B. For example, here my A equals to 1, 2, 3 up to 10, and my B is equals to 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Okay, this is my A and B. Now what I will take? I will take A intersection B. Okay, A intersection B will be all those elements that are in A and in B. Means here one is in A but one is not in B. Therefore I will not consider A1 in A intersection B. Now 2 is in A, also 2 is in B. Therefore I will consider 2 in A intersection B. Similarly 4 is there and 4 is also in B. Now all those elements that are in A and B common, that are nothing but these elements only. Now 14 is in B but 14 is not in A. Therefore you will not consider 14 in A intersection B. It means you should consider those elements that are common to A and B. Okay, this is your definition of A intersection B. Okay. Now next thing we will see some properties of this operation A intersection B. Okay, this was just definition of sets. Again, intersection of two sets will be a set again. Okay, means this property is closure under set intersection. Now next thing is properties of intersection. Properties. As before we have discussed, those sets we are considering in example that are nothing but some subset of universal set U. Means we will consider any set A and B. Okay, consider any sets A and B subsets of some universal set U. Okay, we will take that A and B in our properties. First property says, what it says, A intersection B is nothing but B intersection A. Okay, what is A intersection B is nothing but A intersection B is nothing but B intersection A. That we will see what will happen with this property. Now, what is A intersection B? A intersection B is nothing but X, such that X belong to A and X belong to B. Okay, means what? You can say it as X such that X belong to B and X belong to A. Means what? You will take X belong to A and X belong to B. Means you are taking elements from both set A and B. There I am writing same thing, but just I am writing B first and then A. But what is this by definition of intersection? This will become your B intersection A, right? B intersection A. By definition, it is nothing but elements from B and B elements from A. Okay, means your A intersection B has become B intersection A. Likewise, you can prove all other properties. Now, second is for A, B, and C. Consider A intersection B intersection C. What will happen with this? Okay, this will be nothing but your A intersection B intersection C. Okay, means what? Your intersection is associative. Okay, means A intersection B intersection C is nothing but A intersection B intersection C. Your intersection is associative. Next property. Okay, third property. What will happen with A intersection phi? Can you guess? Okay, we will calculate it. X such that X belong to A and X belong to phi. Means what? We will take all those elements that are in A and that element must be in phi. Means what? You have to consider elements of phi. But the elements are nothing but only empty sets. Okay? There will be no elements in your phi set. Means what? This will become X such that X belong to phi. Why this is so? Since you will have X belong to A and X belong to B. Means you have to take elements of phi also that are common with A. The elements of phi that are common with A are nothing but elements of phi only. Since phi is subset of A, what this will be? This will be nothing but empty set. Since your phi can consist no elements, means your A intersection B has become phi. Likewise, what will happen with universal set? A intersection U. Okay, what it will be? Similar on similar line, we will take it as X belong to A and X belong to U. Means what? We will take all those elements that are in A and that element must be in U. But you know A is a subset of U. Means what this element will take? That what this set will take elements as x belong to A, which is subset of U. Okay? Means you will take x belong to A and which is subset of U, means this will be nothing but your A only. Okay? Means your A intersection U will become A only. But this law is called as universal law and this is called as empty law. Okay? Now next you will see it as, next rule it as, I will write here only. Okay? I will write quickly here. A intersection A. What will happen with A intersection? With itself. It is nothing but x belong to x such that x belong to A and x belong to A only. Means you will take elements of A and A. Means you will take only elements of A. X belong to x such that x belong to A. Okay? But the elements x such that x belong to A is nothing but set A. Okay? Means your A intersection A is A. Means your intersection is idempotent. Right? Idempotent. Okay? This was your fourth property. Now what will be your fifth property? Okay? I will write here quickly my fifth property. That four properties are understood to you. Then we will see the fourth property. What is my fourth property? So fourth property I will consider set A, B and C subsets of U. U is a universal set. Here I will consider A intersection B union C. Okay? I will take A intersection B union C. What it will be? It will be nothing but x such that x belong to A and x belong to A union, B union C. Okay? By definition of intersection, it will be nothing but this set only. Means A intersection B union C will be x such that x belong to A and x belong to B union C. But here you are having your definition of union with you. What it will be? X such that x belong to A and your x belong to B or x belong to C. What it means? Means A union B, B union C is nothing but x belong to B or B or x belong to C. This is the definition of union. Now what this will happen? This is nothing but x such that x belong to A and x belong to B. Now here it is or, means or x belong to A and x belong to C. Okay? This is nothing but x belong to A and x belong to B. Okay? And or x belong to A and x belong to C. Okay? But what this is nothing but x belong to A and x belong to B is nothing but A intersection B. Okay? Now here it is or. Or means union. It is A intersection C. Okay? Means A intersection B union C is nothing but A intersection B union A intersection C. Okay? Means this is nothing but distributive law. What this implies? Your intersection distributes over union. Okay? This is, for example, to prove this thing, I will take one example. It as, for example, here I will consider my universal set as this. Okay? U. And here are my three sets A, B and C. Possible this is my A, this is my B and this is my C. Now I will take step by step A intersection B union C. I will show it as this. Okay? Now for this I will require some more diagrams of this field. That's why I will draw this. We will check this theorem by Venn diagram. Okay? Now this is your A, B and C. First we will calculate B union C. Now my B is this and my C is this. Therefore my B union C will this. Okay? This is my B union C. Okay? Are you okay with this? This is my B union C. Now second thing, I will take A intersection with B union C now. Okay? Here it is my U. This is B union C. Now I am taking A intersection B union C. What it will be? This will be some A, this B and C. Now what is my A intersection B union C? With A, it is making intersection it as this. Is it okay for you? This is my A, B and C. My A intersection B union C is this. Now we will take RHS, what it will become. Okay? Now we will consider our RHS. What will happen with RHS? We will see here. Now I will calculate first A intersection B. Now suppose here my U is there and A, B and C is there. Okay? I will calculate first A intersection B in RHS. What is this? This is A, B and C. My A intersection B is nothing but this thing. Okay? This is my A intersection B. Again, what I will calculate? I will calculate A intersection C. Okay? Now this is A, B and C. Okay? Now what is my A intersection B, C? It is nothing but this part. Okay? This is my A intersection C. Now I will take A intersection B union A intersection C. Means I will take union here. Okay? What this will be? This will be I will write here. Okay? Now suppose this is my U, A, B and this is my C. Okay? This A, B and my C. Now I will consider union of A intersection C and A intersection B. Wait, here it is A intersection B and here it is A intersection C. Now I will take union of them. Means what? I will take elements of A and B. Okay? A intersection B. Also elements of A intersection C. These are nothing but that. But we know we will not consider elements that are common twice. Means this has become your A intersection B union A intersection C. Look at here. This figure 2 and figure 1 is same. Means your A intersection B union C is nothing but A intersection B union A intersection B. This is nothing but the distributive law of your intersection that we have proved by Venn diagram. Okay? Now next thing, we will discuss some other properties of this intersection. What will happen with next properties that we will see quickly. The next term is what is meant by your disjoint sets. And when you say A and B are disjoint, suppose I am having a set A and set B. Means I am having some set A and set B such that A intersection B is equals to 5. Means what? I am having no common element in A and B. Means A intersection B becomes 5. That time you said A and B as disjoint sets. Then A and B are disjoint set, right? Okay? By Venn diagram we can see it as this is my U. Okay? I have told you A and B will be some subsets of some U that I am considering it as here. This is my U set. Now I am having A here and B set here. Okay? So what will happen with this? Now this is my A and this is B. What is the intersection of A and B? There is no elements in between common at A and B. Therefore my A and B has become disjoint sets. Okay? This is the definition of your disjoint sets. Okay? For example, I will take A equals to 1, 3, 5, 7, 9. Okay? And my B is equals to 2, 4, 6, 8 and 10. Now check again what is my A intersection B. Okay? I will calculate A intersection B. It as I will take elements from A and that element must be in B also. What? Now 1 is from A but 1 is not in B. Therefore I cannot consider 1. For this 3, there is not 3 in B. Similarly 5, 7, 9 are not in B. Therefore I cannot consider that element in my A intersection B. Go in B. Now in B 2, 4, 6, 8, 10. These are even integers that are not in A. Okay, therefore my A intersection B is nothing but empty set. Okay, therefore my A and B is called as my disjoint sets. Are you getting? This was my disjoint set definition. Now we will see the next operation or on sets. It has subtraction of. Now it was intersection of A and B. Now next operation is nothing but subtraction of sets. Okay, means you are having some set A and B subsets of universal set U. Now you want to calculate A minus B. What will be the set subtraction? What my A minus B will consist? That you know, subtraction of two elements. You will subtract or you will remove the amount that B set it is. Means, for example, in numbers, I want to calculate 5 minus 3. Okay? I will calculate 5 minus 3. What we will do by doing 5 minus 3 means we will subtract 3 units from this 5 unit. It will become 2 units. Means I am subtracting the number from this unit. But here it is a number subtraction. It is the set subtraction. What happens with set subtraction? Okay, set subtraction will contain all those elements. Okay, A minus B will contain all the elements of A that are not in B. Means we will remove the elements of B from A. Means if there is some common elements, for example, A has some elements of B also, that I will remove in A minus B. Means what I will do, I will take A minus B will take all elements of A that are not in B. Okay, means my A minus B is nothing but elements of A that are not in B. Okay, means I will remove all those elements of A that are in B. Okay, but it is nothing but those elements from A, and that element from A must not be in B. Means X not belongs to B. That you know, X is not belongs to B. Okay, means A minus B will have those elements that are in A, but that element must not be in B. Means we will remove all those elements that are in B from A. For example, here I am considering my universal set as, suppose my universal set as R. Okay, my universal set is R, and I am considering my A as a set of integers. Sorry, my set of integers. Okay, fine. Okay, A is my set of integers Z, and my B is natural numbers. Okay, this B is nothing but set of natural numbers. Now, what I will do, I want to calculate my A minus B. Means what? I will take those elements that are from A and that A must not be in B. Okay? Means what? This will be all those x's that X belongs to Z and X must not be belongs to natural number. Means what these elements will be? I will remove all those elements that are natural numbers. Means I will take 0. Since 0 is not a natural number, my 1, I cannot consider 1 since 1 is a natural number. Okay, sorry, it is not belongs to here. Now 1 is a natural number, therefore it will not be using here. Now here it will be minus 1, minus 2, minus 3 and so on. Means I am not considering positive integers. Why I am not considering that positive integers? Means that positive integers are in A, therefore I will not consider that positive integers. That these are elements minus 1, minus 2, minus 3 that are not in A. Therefore, I will consider these steps only. Are you getting? Means what? You are getting this as negative integers union 0. Okay. By Venn diagram, what it will indicate? Okay. Suppose this is my A, universal set U. This is my A, and this is my B. Okay. This is my A and B. What is A minus B consist? A minus B consists all elements of B that are not in A. that are not in B. Okay, means these are nothing but my elements of A that are not in B. I am not considering elements of A that are here, that are in B also. That will I will just subtract elements of B. That will I will get A minus B. This set is nothing but A minus B. Okay, this is my example also. I am not considering those elements of natural number that are in Z, that are removed. This was your A minus B. Okay. Now we will see some property of this A minus B here. Now suppose consider an example. A equals to 1, 2, 3 up to 10 and my B is equals to 0, 5, 10, 15, dot 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 50. Okay, this is my B set. Now what I will do, I will calculate A minus B. Okay, A minus B. What it will be? It will be nothing but elements of A that are not in B. Now 1 is there which is not in B, 2 is there, 3 is there, 4 is there. Now 5 I will not consider since this is in B. Now 6 will be there, 7 will be there, 8 will be there, 9, but I cannot consider 10 since 10 is in B. This has become your A minus B. Okay, this is your A minus B. Now check whether what is my B minus A. B minus A means what I will take? I will take elements of B that are not in A. Means I will take 0 since 0 is not in A. Now what about 5? 5 is there in A, therefore I will not consider 5. What about 10? 10 is there in A, therefore I will not consider 10. Now next element is 15. 15 is not in A, therefore I will consider it here. 20, 25, 30, 35, 40, 45 and 50. Okay, these are elements that are not in A, therefore I have considered this as B minus A. Now you can observe here clearly my A minus B is not equal to B minus A. Okay, means your negative operation or subtraction of sets is not commutative. Means A minus B is not equal to B minus A. Your subtraction is not commutative. Okay, take it. Now look at it. What is my A minus B? Here it is A minus B. Now go for B minus A. What will be my B minus A? B minus A is nothing but all elements of B. Okay, what is my B minus A? B minus A will be all elements of B, X, such that all elements of B, X belong to B, and that X must not be in A. Okay, means I will consider elements of B that are not in A. Now these are elements of B that are not in A. Okay, you can observe it here carefully. Your elements of B that are not in A are nothing but these elements. Right? Now from Venn diagram, you can see this as A minus B intersection B minus A is equals to 5. You are not having any common element between A minus B and B minus A. Like means next property of your subtraction is A minus B and B minus A have no common elements. What this implies? A minus B intersection B minus A is nothing but 5. Means what? My A minus B and B minus A is disjoint set. Disjoint set we have seen it as if intersection of that set is empty, that set becomes disjoint sets. Here intersection is empty, therefore that two sets are become disjoint. Also now observe here carefully. This is my A intersection B. Okay. This is your A minus B. And this is my A intersection B. You can observe also here A minus B intersection with A intersection B, right? And okay, this is equal to 5, which is also equals to B minus A intersection B intersection A, right? Means your A intersection B with A minus B is also 5. Also B minus A intersection with A intersection B is nothing but 5. Means you are not having any elements common to A minus B and A intersection B. That's why A minus B and A intersection B becomes disjoint sets. Also B minus A and A intersection B also empty set. That means your A minus B, B minus A and A intersection B becomes disjoint set. What this whole thing implies? This implies one property. It as you can start it A minus B comma B minus A and A intersection B are disjoint sets. Okay? Means for any set A and B, you are having its property as A minus B, B minus A and A intersection B as disjoint set. Means you will not have any common element in between them. Okay? This was the small property of your disjoint sets.